Hey guys, this is Coach Lowe, and we're going to talk a little geometry today. We are in section 4.3, congruent triangles. So section 4.3, congruent triangles. And we're going to just talk about congruent shapes also. So obviously this is not a triangle. These are pentagons. But first of all, let's talk about what congruent means. Congruent shapes, or polygons, have exactly the same shape and size. So exactly the same shape and size means they will have the same angle measures and the same side lengths. Everything will be the same. So each part will have the same measure. And corresponding parts, so parts that are related from one shape to the other, or they're in the same spot. Remember, with parallel lines cut by a transversal, we had corresponding angles. They were in exactly the same spot. This is true with corresponding parts. They're in exactly the same spot. So if I picked up this first figure, A, B, C, D, E, and placed it right on top of F, G, H, I, J, corresponding parts would be A, E, and F, J. A, B, and F, G, and then also angles as well. So corresponding parts of congruent figures are congruent. Now, we will change ours a little bit because we will just talk about triangles. So we'll say congruent parts of congruent triangles are congruent. CPCTC is the abbreviation for that. Corresponding parts of congruent triangles are congruent. So we'll come back to that when we work with triangles in just a minute. All right, so congruent polygons here. The corresponding angles will be congruent and the corresponding sides will be congruent. So let's kind of walk through this a little bit here. So I'm going to go ahead and tell you that these two polygons are congruent, and then we're going to identify all the congruent parts. So we're going to show that they're congruent by identifying all their congruent parts. So first let's start with segments. Segment AE is congruent to segment FJ. All right, so I have this one. All right, let's keep moving on. Segment AB is congruent to segment FG. If you would like to pause the video and finish these side links out, that would be great. And you can also go ahead and grab the angle measures if you want to. BC and GH. CD and HI are congruent. And then ED, and JI. That's kind of hard to read, so hopefully you can read that. ED and JI. All right, now let's work on our angles. So angle A is congruent to angle F. So angle A is congruent to angle F. Notice on the sides we use two letters. On the angles, we can get away with just using one letter because there's only one angle with that vertex. So angle C and angle H, if you want to pause the video and finish, you sure can. Angle D and angle I. And the last one, angle E and angle J. All right, so there are all the corresponding parts of that triangle. We took care of the sides and we took care of the angles. Not triangle, pentagon, excuse me. But let's move to a triangle. All right, so in this diagram, triangle ITP is congruent to triangle NGO. Now, it's kind of cool when they write this for you because really they tell you corresponding parts and corresponding angles by the way that they write this statement right here. We are detectives and this is our first major clue. Dum, 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 dum. All right, so what this tells me about angles, I go in order. Angle I is congruent to angle N. So IN in. Remember, if I could pick this up and put it right on top of that one, that's what would match. Angle T is congruent to angle G. Angle P is congruent to angle O. That makes sense? I'm going to grab a drink real quick. Little hot tea this morning. Woo woo. All right, now let's move to corresponding parts. We take these by twos. So side IT is congruent to side NG. All right, then we'll take TP and GO. Side, oop, I put an angle there, didn't I? Let me redo that real quick, okay? Thank you. All right, side TP is congruent to side GO. And then the last one, side PI is congruent to side ON. All right, so let's check out what we have over here. So IT and NG, I'm going to go ahead and mark that. IT goes with NG, TP goes with GO, and PI goes with NO or ON. All right. So we have this angle that's here, so angle O, and we know that angle O goes with angle P, so we should be able to find the value of Y. And once we do that, we should be able to find this side length because we can set it equal to the length of IT. So let's start with this angle measure. So 6y minus 14 equals 40. And I can do that because angle O is congruent to angle P. Angle P's measure is 40. Angle O's measure is 6y minus 14 degrees, so we'll solve for y there. All right, so adding 14 to both sides, 6y equals 54, and then dividing both sides by 6, we see that y is equal to 9. All right, moving to the sides, we know that side IT is congruent to side NG. So let's work that one out. IT is 7.5. And remember, just a reminder on switching from congruent to equals, because maybe you're like, wait a minute, this says congruent, you switch to equal. Remember, definition of congruency is if angles are congruent, their measures are equal. If sides are congruent, their measures are equal. So that's the switch, definition of congruent sides, definition of congruent angles. All right, so we know that y is 9, so we can go ahead and stick 9 in there. So 7.5 equals x minus 2 times 9. 7.5 equals x minus 18. We'll add 18 to both sides. So 25.5 is equal to x. So x is 25.5 and y is 9. All right. Let's get some theorems out of the way and then we'll be finished. All right, 4.3 theorem is the third angles theorem. You have your book with you. The third angles theorem says if you know two of the angles in a triangle, and if they're congruent to two angles in a second triangle, then we know that the third angle is congruent, right? So if I have two triangles, let's say, I can't find my little, oh, there it is. Triangle ABC and DEF. Triangle ABC and triangle DEF. If we know that angle A is congruent to angle D, meaning their measures are equal, angle B is congruent to angle E, then by the theorem, the third angle theorem, we also know that angle C is congruent to angle F. All right, so that's the third angles theorem, theorem 4.3. Theorem 4.4. Properties of triangle congruence. All right, reflexive property. Triangle ABC is congruent to itself. So these will sound really similar to the reflexive, symmetric, and transitive that we've used before. Symmetric property. If triangle ABC is congruent to triangle DEF, then we can flip those around. Triangle DEF is congruent to triangle ABC. And then transitive, we know what that is, don't we? This is going to involve 3 triangles. Transitive property, if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle GHI, so 1 to 2, 2 to 3, then that takes us 1 to 3. All right, so let's finish. Then triangle ABC is congruent to triangle GHI. We'll work on a few baby proofs in class together and work some more examples like the ones that we've looked at today. All right, guys, this is Coach Lowe, and I'm out.